please. Okay, yes, okay. Thank you very much for that. So I want us to pick up a slightly new topic, which is very, very fundamental in terms of distributed systems. And this is called network file systems. Network file systems. So network file systems basically looking at a distributed environment structure. So in this discussion, presentation today, I'm going to be able to look at the principles behind network file systems. Then after that, we can on maybe specific implementations of that. The file now focus. So network file systems, like I mentioned, is very, very key to be able to ensure that the distributed system works. Now, think about it. So if we mention a recap, so we are saying in a distributed environment, we have resources that are distributed widely. So they can be global, they can be within the region, depending on where you have set up your system. But of course, if you're using the internet, you are looking at it as a global aspect. So since they are distributed, therefore, we need a distributed file system. Okay, we need a structure that handles that file system so that we can be able to use. So this distributed file systems discussion talks about time sharing. Now, time sharing simply means you use a file, the same file. We can use at the same time. That means the copies we change will be different where we are changing, or can use it at different times. So that's part of file sharing. So it's a time sharing, classical time sharing model of the file system, where you have multiple users share files under storage services. So key point here is that basically they can be able to share files and storage resources. So those files are on dispersed storage devices. So we have dispersed storage devices that are having those different files, okay? And they might be replicated. Replicated means exactly the same copy, okay? Or so we can have multiple copies, or of course they might just be different files, okay? So the overall storage of all those files is managed by what we refer to as the distributed file system, okay? And this means that those distributed file, the distributed file system will be able to manage smaller storage spaces that are different, okay? So keywords here, they are different in terms of maybe architecture. They're remotely located and they are small, okay? But cumulatively, we are looking at a very big number, okay? So cumulatively is a big number. So cumulatively, we are talking about a big number, but they are in different places. So that means that we must have, okay, some correspondence, okay, correspondence between the different storage spaces, okay? So we must have correspondence means how do I know where my file is, okay? And what are the files? So I have storage spaces and set of files. So we must have correspondence. That means that if I try to access a particular file, I should be able to say that this is the file I'm trying to access. That's what we mean by correspondence.
Hebu rudisha hiyo kitu huko, ni kitu yangu hiyo.
Hello? Someone is trying to. Okay, so if we continue from where we were, so we have those distributed files. For us to be able to have that correspondence I was talking about earlier, we need to ensure that they are named. Okay, so naming becomes important, and there is a mapping between logical and physical. Physical indicates where they're actually stored. Logical means the way you have organized them to be able to behave, to be able to interact. So, but it does not tell you where it is. So physical would be where on which particular server, and the linkage maybe the IP and whatever. That's physical. Logical, I can simply say this file will be connected to this. Those files might be in different locations. So we must have between logical and physical. So that mapping can be multi-level mapping. Multi-level mapping means I can have the list of names, like you maybe might use a name server, okay? And I have the location where they are in storage elsewhere. And then in between, I have a map. So look at it as maybe the way you can do routing. So you have some way to be able to indicate that if you want this particular file, you can be able to access in this location. So that's what we mean by multi-level mapping. That is an abstraction of the file that you want to access. But one important thing to remember that when we do multi-level mapping, the details of the file and where the file is on the disk, okay, is this information is not known to you. That's what you mean by abstraction. It's not known. So when you're trying to access a file, you are not simply saying that this particular file I'm accessing is in this location. No. That's the work of the distributed environment to be able to help you do that. And that means the concept we have talked about before, which is very, very important in terms of distributed system, the concept of transparency. So the multi-level mapping, so you abstract a file such that you hide the details of how you are actually accessing that file and where on the disk that file is stored. So this is the concept of what we call a transparent DF. So it hides the location, okay, where the file is on the network. Okay, it hides that particular location to you. And of course, this is very, very important for several reasons we'll talk about later on. And even if you have replicated file on multiple sites, okay, that means you have multiple copies of a particular file, their location is also hidden from you as the person who is trying to access that particular file. So to recap, logical, yeah, where how you want it structured, physical, where it is or located. The multi-level mapping will hide the details of how and where, and this means that we have a transparent distributed file system. So the location of on the network, you don't know where it is, and the location on the network, you don't know where that particular file is. And even if it's replicated, so replication means we have multiple copies of that particular file. So all is also hidden. So we end up getting the concept we talked about, transparency. So it is transparent. is the same, that now all the information is hidden. Now, how does that look? Which kind of transparencies are related to this? Okay, so from my last slide, I mentioned transparency. So we have two. We have location transparency and location independence. So when we talk about transparency, we are saying the file does not reveal, okay, does not reveal the physical storage location. Does not reveal the physical storage location. Okay, so we say that is location transparency. So although the file is still not specific, you can actually be able to get that information. Okay, and usually this happens if you have an exception. You'll get the details. So although it still gives a specific, although hidden set of physical blocks where that file is, but in terms of usage, that information is not available to you. So like we talked about when we are remote method invocation, we are saying that information, the distributed environment just helps you to be able to access that information without you considering in things like maybe network, a socket or network programming. So this makes it easier to have a convenient way to share data. Because as a user, I don't have to know where that particular file is. I don't have to know the storage location. So I don't have to even think about programming it. I simply have to know that this file exists and I want to use it. Of course, there are scenarios where, with exceptions, you can expose correspondence. So when there's an exception, you'll know which computer failed. So that happens. So when when you have exceptions being thrown, you'll have the component units and machines can now be known. Okay, component points and machines can be known. Now, when an exception, you can be able to know this because it exposes these different elements. The other one is location. That's the only location independence. Okay, the file name. Okay, in location independence, we are saying the file name does not change when the storage location changes. Okay, so if I had a file name in one location, okay, and I move it to a different location, that file name does not change. The file name does not change. Okay, so that means that I can access, I will still access like nothing has happened. Okay, so that is what we call location independence. So location independence now means that we can now have better file abstraction. Okay, so we don't have to worry about denoting, adding more details about that particular file. We just change it and move it to a different location, but it can still be accessed because that distributed file system will be able to organize and tell you where that is. And so that means it can promote sharing of the storage space. Okay, so if I have one area that has enough storage space and another area has maybe limited storage space, I have an opportunity to move that particular file to a different. And so we end up doing something very, very important in terms of distributed systems. So we separate key from devices hierarchy. How we name. So remember, in your location, let's say your laptop, you have file in folder A, and inside folder A you have B, another folder, and so forth until you get to the leaf, which is the actual file. So we separate the naming hierarchy from the storage devices hierarchy. Okay, so that when we move, we just move that to a different location, and then we can still be able to access. Okay, and so in this case, the file, we end up with a concept we refer to here as location independence. Now, before we show how this is implemented, we need to think about, let's revisit the concept of naming again. Okay, so files, of course, can be named based on one way would be a host name, okay, and of course a local name. So this will guarantee a unique system-wide. So yours and mine will be different because the host name is different, okay? Even if we are using a local name that is shared, but the host name is different. So that's one, a combination. And the other one is where we attach remote directories to local directories. To my and access them. Okay, so your files are remote to me. And then access them. Okay, so, and when you do that, you end up with a very interesting way of whereby we end up with a coherent directory. So if I look at now my local location, it's as if those particular set of files, okay, those particular set of files were exactly on my local directory. But for that to happen, we need to have previously mounted. So mounting is a concept we're going to discuss. We need to have previously mounted the files. So it means for me to attach remote files to my local directory, we need to have done something we call mounting. And this, the moment that is done, we end up now being able to access those files transparently. So the access of files transparently means that we must have mounted them. Okay, the moment we have mounted those files, okay, we're using the network file system, I can now access them as if they are in my local location. So now what happens is that now I end up both local and remote files as if they are in my location. I access transparently. Okay, now the other one, okay, way of doing that is total integration. Okay, says them. But now the problem with this concept here is that the server is an available arbitrary set of files on different machines become unavailable. Okay, so that means that the servers, because remember mounting, we can mount files from different locations. So those ones that were on a server that is unavailable are the ones that you cannot be able to see, but you can still be able to see those ones that were able to be mounted. So to recap that, I can simply maybe go back and use this. So we have this part here, files, this part, files, we do that, a combination of hostname and local name, unique system-wide, or we attach remote directories, local directories, okay? And remember, for us to do this, we must have mounted them, okay? And then we can transparently access those files. And then we can also be able to total integration of files, okay, with a single global name structure. So that means that we can be able to have them accessed from a directory structure that spans from one single point of start. But the danger of this is that those servers that go down, you cannot be able to access those different files. Now, this concept of I have mentioned here this part here of remote directories. So you access files remotely, okay? So how is that done? How do you actually access those files, okay? So remote file access So if we do remote file access, we are saying that all the things we're doing, we incur traffic. Now remember, okay, I have to mention this, yeah? Remote file access means I can be able to access a file that is remote, yeah? And for me to be able to, remember, when I save that file, it needs to be updated. Remember, you're accessing it from a server. That is the location where that file is supposed to be kept. So if I'm accessing it on a server and I am making changes in my location, how can that be done easily? I need to have a cache. Okay, so the cache ensures that the changes I make to my file are handled locally. So the file is on a server elsewhere, but I am making changes on a file that is already accessed, stored in a cache. So if therefore, it means therefore, if I want to be able to use a file that is not already cached, I need to have a copy brought from the server to the user. And then the accesses are performed on the cached copy. The access copy. That master copy is where we can make that is the location that has the master copy of that particular file, such that when we save, the file can be updated to. Okay, so that means that we have different caches that are scattered across the different parts of the file. That we potentially have a problem we call cache consistency. Okay, so we end up having a problem we refer to as cache consistency problem. I have a file A, you have a file A, another person has a file A, and each one of us is making changes to that particular file. And of course, we are changing in different locations. So that means we have a cache consistency problem. Okay, so, and these are some of the things we'll have to discuss later on to see how do we resolve that. Okay, therefore, keeping cached copies consistent with the master file is one of the problems of a distributed environment. So we need to be able, as we're looking at accessing files using this concept of remote file access, we need to be cognizant of cache consistency problems. Okay, so maybe before I feel our questions to complete some of the maybe issues, maybe questions people have. Let's see how the implementation is done with a cache, okay, and the differences. So of course we can have a cache on a memory to support the memory, and we can have a cache to support the disk. So what are some of the advantages of using disk cache? Okay, so some of the advantages, of course, more reliable. You know from experience that is as a source that is much more reliable as opposed to memory. Post cache copy is kept on the disk. So if there's any problem, we can requires a recovery. We can always go back, and then we can be able to get that particular copy. Okay, so of course, so it's always good to have disks. But in terms of implementation, we might also want scenarios where we just want only main memory caches, just to support the main memory. So because disks might be expensive, okay, and if you consider from computer organization, reading a disk is much harder compared to this reading main memory, of course. So if you're using main memory, you have accesses are much quicker, okay, which is good. So some of the things we need, so we can have speed, performance speed up, especially maybe if you for bigger memories, we might want to do that. And then, of course, we can support them by server caches to speed up input-output disks. So regardless of where the cache is, okay, when the user caches are located, main memory caches are there to support some single caching mechanism. Okay, single caching mechanism, we are saying that between the server and the main memory, we need a caching mechanism that is single, in the sense that, okay, we don't want them to be different in behavior because that will complicate our files. So we need a single caching mechanism. So the caching mechanism that we have on the server and the caching mechanism for the memory should be a single caching mechanism. Basically, in the same way, so that we don't have discrepancy in terms of. Now, if you have cached results, or one of the things that will come up is a user. The first one, how do I update that? So we write through policy or write through a delayed write policy. Okay. Now, write through policy or write through a cache update policy says that, okay, cache update policy says that when you make any change to a file, data, you write it through to the disk as soon as it's placed on the cache. Okay, so you update you write the information, immediately you put on the cache, you write it straight to the disk. So that is reliable. Okay, so reliability is an important thing, but of course is poor performance, because the way the cache works is that if I have to send information on the disk, I have to confirm the disk has saved that information before I can delete it from the cache. So if there is a problem, then it will waste a lot of time trying to coordinate until the two are in agreement. That is poor performance. So let's think about another policy, delayed write policy. So here now, delayed write policy, we make changes on the cache, save them on the disk later. So if we do that, what is going to happen, okay, is that we have write access that are completed quickly. Because remember, the first one we are saying, if I write on the cache, it has to coordinate with the server and ensure that the information is complete. So between you writing and cache and the disk, the three of them have to work together. And the cache to ensure only on the cache. And you will save this information and you write it later back to the disk. So you no need to be written to the disk, but we have issues there. Poor reliability. The poor reliability here is, supposing your node goes down, all the changes you have made will be lost. So those ones cannot be sent to the server. Okay? So that means that the data you have, at any moment, all the users that are making changes, that information is not reliable. So let's try to improve that. Let's think about how we can improve that to see reliability. So we can have something called variation. So we simply scan the cache at regular intervals, and flash blocks that have been modified scan. Okay, so that means that we have a variation where we scan the cache, and then we flash. So basically, we move that information right to the disk, so that we don't keep on having it there for long. So if something has not been changed in a certain interval, okay, we have it saved on the disk, and in case we need it, we'll get it back. But basically, it means that if my node fails in that particular interval, I still have at least some updated information on the server. Okay, on the disk. Sorry, we can have another variation, write on close. So write on close says that we write when we close. So whenever you close a file, then that file is triggered to be updated on the disk. Now this becomes important for files that are modified for long periods, or files that are frequently modified. Okay, so I don't have to keep sending it to the server and bring it back, server and bring it back. No. I can work on it for a long period of time, and then when I write, I close. Of course, this has you have to look at this and remember one of the issues we had at the top here. Okay, this one here of poor reliability. You'll have that will, so if it fails, even if you have made so many changes, of course you will lose that. But we're just trying to look at possibilities of how this can be done. So the issue I mentioned about consistency before we field questions. Now, how do we maintain consistency? How do we maintain consistency? Consistency, I'm saying, how do we ensure that the file that I have in my location, remember what we have discussed on the last slide. So we can either have delayed write or write through policy. Right, hashed copy, okay, and the master copy. How do we ensure that is done? So we can have two ways of handling that. We can have what we call client-initiated approach, and the other one is server-initiated approach. So client-initiated approach, we have that in this case here, the client initiates the validity check. Okay, so we are saying, as a client, I have cached a copy. I am using that particular file, but I can go and ask the server, hey, this particular file that I'm using, I might just not be even changing. I might just be reading the file and check, just reading the file only. Okay, so I can ask the master copy, the disk, this particular file, is it still valid? Okay, and so the server checks whether the local data are consistent with the master copy. So it can tell you, oh yeah, that particular file is still valid, and you can continue using it. Or is it invalid? And we'll talk about techniques of invalidation, where you are told that particular file can't work. We look at the techniques in which we can use to say, how do you proceed when your file is invalid? Okay, the other one is server initiated. So this, we remember, the concept we have here in the display environment is client server model. So we have a client that has cached a copy, so it can initiate that interaction, or the server that keeps the master copy can initiate. And so the server can, at regular intervals, okay, for each client, it can check, okay, which parts of the file that particular client, okay? And then if there are changes in that location, so if the server detects inconsistency, it must react. And part of the reaction is what I mentioned. It might simply say, hey, that particular file is invalid. Please instead, let's get a new file, or get this particular file, okay? And so in that case, therefore, the server has initiated. And that means, you notice what is happening here. That means that the server must know all the clients that are interacting with a particular file. Okay, so I think time for questions maybe, and then we take a short break. Anything specific that maybe you might want me to expound on before we proceed? Okay. Let me. I have two questions here. A cache update policy and location independence. Okay, so let me maybe recap those ones quickly before maybe we take a break. So let me go back here. So in a nutshell, what we are saying here, right through policy is that when you, okay, let me start from this point. We have clients and the servers. So when a client needs a file, it can get that file from the server. And that file is kept on the cache of that particular client. And then that's called write through. So you make a change, you write through all the way. Write through simply says you write to a cache and you write all the way to the server. So that is a write through policy. Okay, so we say it is reliable because all the changes are accepted. Remember, the server is the master location. So it's reliable because all the changes you make are stored there immediately. The delayed write policy simply says, if I have copied a file, I have cached a file from the server, I can make changes and update the server later. So it means all the changes that I'm making, I'm using my local copy. Now, the first one, it means that when you update, you are always with the same copy with the server. You are always at the same level in terms of pages. But this other one, I might have changes on my copy that the server is not aware of because it's delayed write. And so if I make changes, overwrite those ones. Okay, so I'm just overwriting what is on my cache. So we said one of the problems is poor reliability because if the client crashes, I lose that information. To improve that, we might have a variation where we are saying that at regular intervals, maybe let's say a few seconds or maybe 10 seconds or maybe 5 minutes, whichever, okay? We flash the blocks that have not been modified since the last cache. So flashing simply says you force them out into the server to be saved. So I don't have to have them because I'm not making any changes to them. Or the other one is here, variation, write on close, which simply means I write a server and as long as it's still open, I can still be able to make changes without telling the server. And this can be good for long periods of time where I need to change a particular file because it means that I don't have to save and then I'll tell it, save this one, save this one. No. I save, I keep on working on it and then save later. Okay, or if I have a file, I keep on changing, frequently modify. I keep on changing and changing. So that particular file, there will be no need for me to send to the server. And hence, these two update policies. The other one, let me go up here. There was the concept of location transparency. Okay, sorry, I didn't clear my drawings. So the concept of location transparency, okay, and location independence. Location transparency, we are saying the file does not reveal the physical storage location. Maybe you joined later, but if you joined us earlier, what we have said is that files can be accessed. There are files stored on servers, and clients can access the files without you copying the files in the location. Okay, so files do not reveal the physical storage location. So I am accessing a file, but it does not tell me it is in location A or location B. What is the advantage of that? Your users cannot know. Supposing they sabotage, I cannot sabotage that location because I don't know. Of course, you can get, but with effort. Okay, so of course the file still has a specific, although hidden, set of physical blocks. You can get it, but it's not something you have to go an extra mile. And one of the areas that you easily have this exposed is when you have an exception, because exception will tell you server A has failed, and will tell you the particular file. So it might be able to reveal even the file structure, okay, depending on how that server has been set. So, but it's hidden. So that means that it's convenient to share data. So I can move things around, okay, but we can be able to share data, those files, without necessarily struggling to know how they are structured, okay? This last part here of correspondence is where I said, if something fails, of course, you'll have to know, okay, which server failed. And that's why you remember the first definition we had for a distributed system was, you know you have a distributed system when a file you have never heard of fails. Okay? Location independence, just to finalize on what you're saying, location independence, file does not reveal, okay, when you change from one physical location to another physical location. So if I change it from B to C, the file does not, my access does not tell the file has been moved. So in my presentation earlier, I said, I might be using a file that is stored in location B. Tomorrow I use the same file is in location C, but I will not know the difference. Okay, so that means that it gives us a better file abstraction to help store that information, and then promotes sharing of storage space. If I have my excess storage space, I can simply be able to have files stored in my location. So we separate how the hierarchy of files, the way they are stored in the directory structure, from the storage hierarchy. Because the storage hierarchy, we have, if we look at it, we have the caches, we have main memory, maybe we have the disk, and then we have maybe larger, maybe disk space. So that's the storage hierarchy. So we separate them totally. And in the sense, we attain what is called location independence. Okay, so I think let's maybe take some 5 or so minutes break. And during that break, feel free to, if you have questions or things that maybe you want me to pick up when you to show the implementation. Okay, how do you use caching and how do you use remote service on the distributed environment? So let's take that break. 5 minutes, I think, is good. Spread, walk around. Don't have what we call Zoom fatigue. Okay, so 5 minutes, and then we get back. Okay. Welcome back. Welcome back. So we begin. Wangari, I'll get back to you on your question about local directory and total integration in a short while. After I have explained some of the concepts, if this will not have been captured, feel free to ask again this one here. Okay, so another very important thing that we need to consider, the differences between caching and remote service. So these two, okay, these two concepts here, we can differentiate them by the way it works. So caching, of course, you know you have it in your, you have the copy on your location, okay? Remote begin again. I'm sorry about what happened. So that we can get back. Can someone hear me? Okay. So fine. So let's get back to what we are discussing. But the good thing is that it came just after break, so we hadn't gone much. So even if I'm looking at the videos, they'll be continuous. So there in caching, okay, there are two where you can cache and you can have remote access. Means you have the information on your local disk and you change, okay, and store later. The policies we talked about later will still hold. You store it later. Remote access means that everything you do is being handled remotely. Okay. So caching, I have my file in my location. I make changes. I can store it. Remote access, I have it, even if I have a cache, but all the things are being done. I make the changes that are going all the way to the server. So servers are conducted only occasionally in caching. Okay, or only occasionally. Okay, so this means that we reduce the server load and we also reduce the network traffic. Okay, and this enhances potential for scalability. Now, remember the concept of scalability. Okay, scalability means that I can be able to have that information, or I can have many users spread out, maybe in terms of organizations or out. We can be very far because we are not overloading the server. So that's what we mean by this concept here. It enhances potential scalability. Okay. Now, remote file access means that everything I do, I have remote access across the network. So if I have a file that is on the server, so when I there's the concept here we're trying to look at earlier on in terms of caching. So we are trying to compare. Caching and remote service. Caching and remote service. Okay. So I had mentioned that caching, many of the remote accesses are handled by the local cache. Okay, so we are saying all the changes that you do are done at the local cache, and that means that they are fast because everything is being done at your location. Now, so servers are only conducted only occasionally in caching because the copy is at the local cache, and so you simply you check with the server for maybe any new things, but everything is done at your location. So that reduces server load because the server is giving services to several different clients, and therefore you reduce the server load, and of course you reduce network traffic and increase potential for scalability. Okay, potential for scalability are in the same that as long as you have caches that are storing the information globally, then you can move as far as possible physically, okay, geographically, and also even in terms within the organization. That's caching. Remote service, on the other hand, okay, every remote access across, okay, everything that you do is done across the network. So it means, therefore, that all the changes you make to it will be handled on the network, okay, and that means that you have penalty in network traffic. Okay, so remember this other one here, we had reduced network traffic, but this one you have penalty because you are keeping on accessing it from the server, you are loading the server, and of course you degrade performance of that particular service that you have. So that means that the two, we can compare them in terms of that. So either you are doing it by caching or you have it by remote access. Now, when this remote access, we can expound it and say that basically total network overhead can be found when you transmit large chunks of data. Okay, so if you are caching, transmit large chunks of data to your location. Okay, of course, this will depend on the kind of service. Okay, but it also means that if I will move it close to where I am. Now, if it was remote service, notice I will not move. Remote service means all the things I'm doing are at the server. Okay, so I don't have to transfer a file across the network to come and cache it. So that's the beauty of using remote service. So if I have large chunks of data, I would rather use the server because I will not transfer it. But if I'm data caching, I have to transfer to my location. Are there any advantages of these two techniques? Of course, caching is superior in accesses, okay, if you have infrequent writes, okay? So if I'm not writing severally, that means I'm not updating the information in the server severally, then it means that the caching is superior, okay? Because I will have my cache, okay, and then I have the file staying with me for a long time. Okay, so I have that information on my local disk, okay, or my large memories, and then I can be able to use that. So this means that I can now be able to use, okay, diskless access, okay, or maybe smaller memory, because in this scenario, what I'm simply saying is that I just have a smaller memory and I keep everything on the server. I just make changes on the server. So I can have a very small